points, we have 2 points. The question is, the points lie on the graph of equation of line 3x plus 5y equal to 14. So we should know whether the point is lie or not on the graph. The point lie means it should be satisfies the equation. So check the first one and replace x by 2 and y by 1.6 in the given equation and simplify the equation. So x by 2, so 3 times 2, 6, and y by 1.6, 5 times 1.6 will be 8. So the value is 6 plus 8, 14. So both sides are equal, hence it satisfies the equation. So the point lies on the graph. We should give the conclusion of the question, so the point lies on the graph. Same like we have to check for the second point. So you have to replace x by 1 and y by negative 2.2 in the given equation. So 3 times of 1 is 3 and 5 times of negative 2.2 is negative 11. It gives negative 8. It is not same because right side we have 14 but left side we got negative 8. So hence the conclusion, the point doesn't lie on the graph. Next we talk about equation of circles. The standard form of equation of a circle is defined x minus h square plus y minus k square equal to r squared. And we know the circle which depends on the center. The fixed point we call center, and in generally we give center h comma k, and the equal distance we called r, radius. So if I know the center and radius of the circle, and we can form a standard equation of the circle. So look at the example 11. Write the standard form of equation of the circle with radius 2 and center negative 1 comma 3. So I have h, so h equal to negative 1 and k equal to 3 and radius, and we mentioned this is r. So in the question we have r, h and k. So in the general form of equation of circle, you just replace h by negative 1, k by 3 and r by 2. So here we have minus of minus will become plus. So x plus 1 square plus y minus 3 square equal to 2 squared will be 4. So that's it, simple. And another way of question we can ask, we'll give you the standard form of equation and we may ask you to find center and radius. So for this case, you have to compare with the general form. So what is in the place of h? I have actually the general form we have minus, but here we have plus, so h must be minus 1. And when you compare the place of k, I have 3, so k equal to 3. And this is same like y minus, and here also y minus, so k must be positive. And for find the radius, you need to take the root of the value. So what is square root of 4? It is 2. So in the two ways we can ask question. One is center and radius will be given. We ask to find the standard form of equation, or standard form of equation will be given. We ask find center and radius of the circle. Next, symmetry of equation. The graph has symmetry with respect to y-axis. Okay, we have to replace x by minus x. If it gives the same equation, then we can say the graph is symmetric with y-axis. For origin, we need to replace x and y by minus x and minus y. It gives the same equation, then we can conclude the graph is symmetric with respect to origin. For x-axis, we have to replace y by minus y. It retains the same equation, then we can say the graph is symmetric. But picture representation, how we can find the graph is symmetry? See, the first graph, it is symmetric with respect to y. And by the way, always even functions are symmetric with respect to y-axis. And when you divide the graph with y-axis, the image, it is the, on the left and right side, it's a mirror image. So that we can say the graph is symmetry with respect to y. For x-axis, you can divide through x-axis and look at that. The image of the graph is the same on the above and below of the x-axis. So we can say the graph is symmetric with respect to x. But origin, you need to turn around the graph 180 degree. I cannot turn, but you can check in the book. You can turn around the graph 180 degree. So the graph will be the same. Then we can say that the graph is symmetric about origin. And by the way, the graph symmetric odd functions are symmetric about origin. But a graph is symmetric to x-axis. It's not a function. The question, test y equal to x squared plus 2 for its symmetry with respect to the x-axis, y-axis, and the origin. So for testing, the graph is symmetry. For x-axis, we have to replace y by minus y. So when you replace y by minus y and it gives the same equation, then we can say the graph is symmetry. But if you replace y by minus y, the graph is not the same for the given equation. You have to compare with the given, because in the given equation y is positive, but the resulting equation y is negative. So that is not symmetric about x-axis. And for checking y-axis, we have to replace x by negative x. So when you replace x by negative x in the given equation, we have x power 2. So it becomes again the same positive value, because minus x the whole squared will become positive. So whenever you have the variable with even power, it gives the positive value. We know that. So the graph is the same. Hence, this graph is symmetric respect to y-axis. And for origin, we have to replace both x by minus x and y by minus y. So when you replace y by minus y, it becomes minus, but x by minus x, it becomes positive. But anyway, the graph is not the same because y is having negative value. Hence, the graph is not symmetric about origin. And this is graphical representation. This graph is symmetric about y-axis, right? If you divide through y, it gives the same on the right and left. So hence, the graph is symmetric about y-axis.